Let's do two simple examples of electric fields and voltages. So for the first, let's imagine an electrical plug. So you've got an electrical plug here, and you're plugging it into a wall socket. Okay, so now let's say that when you plug it into the wall socket here, that it's not all the way plugged in, and so what happens is that you've got this plug here, and these two metal plates are sitting here, and they've got 120 volts between them. Okay, the separation between those plates, the separation in here is typically about 11 millimeters. So I want to know, assuming one's positive, one's negative, or really more one's positive, one's zero, but assuming that, then the electric field is going to go from one to the other, and I would like to know what is the magnitude of that electric field. So, magnitude of the electric field. All right, so well, we know that the difference in voltage is integral E dot ds. Okay, so with that, let's draw that a little bit clearer. So with that, then we would say that the electric field's constant between the two. We're going to assume that the electric field's straight between the two. It's not really, it is arching a little bit at the ends, but we're not going to worry about that. So we're going to assume it's straight between the two. So the difference in voltage is just going to be E times D, where D is that separation right there. Okay, so in that case, then E, it's just going to be the difference in voltage divided by D. Well, in this case, then the E is going to be 120 volts divided by 0.011 meters. Okay, and so you just divide that out. And that is going to be 10,900 volts per meter. Okay. Now, it turns out it's a little more complicated than that, because wall outlets, what you're getting there is you're getting that this is AC, not DC, so it's a little bit more complicated than that, but this is just to give you a ballpark idea as to how to figure that electric field. Now, in the engine of your car, you have a spark plug. Okay, and so the spark plug here has a gap, and there's a difference in voltage there. Okay, and so there's a difference in voltage between the plug and the little arm there. There's an electric field between there, and what happens is, in order to get a spark, we know that in the air gasoline mixture, in order to get a spark, then you need an electric field that is approximately 3 times 10 to the 6 volts per meter. Okay. The plug gap, okay, so let's say that distance there, okay, the plug gap is going to be equal to 6 millimeters. So I want to know what voltage is necessary. Well, that's the same sort of thing. Voltage can be E times D. And so what that means is that the voltage is going to be 3 times 10 to the 6 volts per meter, okay, times 0.006 meters. So the voltage comes out to be somewhere in the vicinity of 1800 volts. minimum. And in fact, there are a couple thousand volts in the plug wires. And one thing you can sometimes realize is the plug wire insulation is not 100% efficient. And so if the engine's running and you lean against the chassis and then grab a plug wire, then you get a little bit of leakage through you. And it's not, it hurts. So you don't want to do that ever. Okay. Sometimes at night, if you have old plug wires, then you can turn on the engine, open the hood while it's not parked under any lights or anything in the dark, and you see little sparks flying all over the place. And that's because the plug wires, the insulation starts breaking down. Of course, if the sparks are going someplace other than to the spark plug, then you're going to occasionally get a miss, and a cylinder doesn't fire. So that's why for older vehicles, one of the things you do is after a certain length of time, you change the plug wires. So it's either a certain number of miles or a certain length of time. Really, it should be a certain number of cycles of firing, but that's harder to figure out. So normally the recommendations are a certain age or a certain number of miles that you've driven. But these are two really simple examples relating the electric field and the plugs, or the electric field and the voltage.